Hi guys, we're back with a new video. For this video, we're going to talk about the summary of the given chapter, which is the chapter 9. So let's proceed. So the transport layer, data networks and the internet supports the human network by supplying reliable communication between people. On a single device, people can use multiple applications and services such as email and the web and the instant messaging to send messages or retrieve information. Data from each of these applications is packed, transported, and delivered to the appropriate application on the destination device. Role of the transport layer. The transport layer is the responsible for establishing the temporary communication session between two applications and delivering data between them. An application generates data that is sent from an application on a source host to an application on a destination host. This is without regard to the destination host type, the type of media over which the data must travel, the path taken by the data, the congestion on the link, or the size of the network. The transport layer is the link between the application layer and the lower layers are responsible for network transmission. Transport layer responsibilities. Tracking individual conversation at the transport layer, each set of data flowing between the source application and destination application is known as conversation. So a host may have multiple applications that are communicating across the network simultaneously. Each of the application communicates with one or more application or one or more hosts. It is the responsible for transport layer to maintain the track this multiple conversation multiplexing, sending some types of data. So for example, is a streaming video across the network as the one complete communication stream can consume all of the available bandwidth. This will prevent other communication from occurring at the same time. It would also make error recovery and retransmission of damaged data difficult. The TCP. TCP transport is analogous to sending packages that are tracked from source to destination. If a shipping order is broken into several packages, a customer can check online to see order of the delivery. So with the TCP, there are three basic operations of reliability. Numbering and tracking data segment transmission transmitted to specific host from a specific application. Acknowledging received data. Retransmitting any acknowledgement data after a certain period of time. UDP. While the TCP reliability functions provide more robust communication between applications, they also incur additional overhead and possible delays in transmission. There are trade-offs between the value of reliability and the burden it places on the network resources. Adding overhead to ensure the reliability of some application could be reduce the usefulness of the application can even be detrimental. In such cases, UDP is better transport protocol. The right transport layer protocol for the right application. So for some application segments must arrive in a very specific sequence to be processed successfully. With other application, all data must be fully received before any is considered useful. In both of these instances, uh, TCP is used as the transport protocol. So application developers must choose which transport protocol type is appropriate based on the requirements of the application. TCP features. To understand the differences between the TCP and UDP, it is important to understand how each protocol implements specific reliability features and how they track conversations. In addition to supporting the basic function of data segmentation and reassembly, TCP also provides other services, establishing session, reliability delivery, same order delivery, So TCP header. TCP is a stateful protocol. A stateful protocol is a protocol that keeps track of the state of communication session. To track the state of a session, TCP records which information it has sent, which information has been acknowledged. The stateful session begins with the session establishment and ends with closed with the session termination. UDP features. User Datagram Protocol or UDP is considered a best effort transport protocol. UDP is a lightweight transport protocol that offers the same data segmentation and reassembly as TCP, but without TCP reliability and flow control. UDP is such a simple protocol that is usually described in terms of what it does not compared to TCP. UDP header. UDP is a stateless protocol, meaning neither the client or server is obligated to keep track of the state of the communication session. If reliability is required, then using UDP as transport protocol, uh, it must be handled by the application. Multiple separate conversion. The transport layer must be able to separate and manage multiple communication with the different transport requirements needed. User expect to be able to simultaneously receive and send email to instant messages, view websites, and conduct VoIP phone calls. So each of these applications is sending and receiving data over the network at the same time. Port numbers. So the source port number is associated with the originating application on the local host. The destination port number is the destination application on the remote host. Socket pairs. The source and the destination ports are placed within the segments. The segments are the encapsulated within a IP packet. The IP packet contains the IP address of the source and destination. The combination of the source IP address and source port number or the destination IP address and destination port number is known as the socket. Port number groups. The Internet Assigned Number Authority or the IANA is the standard body responsible for assigning various addressing standard includes the port number. There are different types of port number as the number one is the well-known ports, the registered ports, and the dynamic private ports. The netstat command. An explained TCP connection can pose major security threat. They can indicate something or someone is connected to the local host. Sometimes it is necessary to know while active TCP connections are open and running on the network host. TCP session termination. The close a connection then finish FIN. Control flag must be set in their segment header. To end each one-way TCP session, a two-way handshake consisting of FIN segment and an acknowledgement segment is used. Therefore, to terminate a single conversion supported by TCP, four exchanges are needed to end both sessions. TCP reliability. So, TCP segments may arrive at their destination out of order. For the original messages to be understood by the recipient, the data in these segments are reassembled into the original order. Sequence number are assigned in the header of each packet to achieve this goal. The sequence number of represent the first data bytes the TCP segment. TCP flow control. So the TCP also provides the mechanism for flow control, the amount of data that our destination can receive and process reliably. Flow controls have maintained the reliability of TCP transmission by adjusting the rate of data flow between the source and the destination for the given session. TCP flow control congestion avoidance. When congestion occurs in the network, it results in the packet being discarded by the overloaded router. When packet containing TCP segments don't reach their destination, they are left acknowledged. So by determining the rates at which TCP segments are sent but not acknowledged, the source can assume a certain level of network congestion. UDP diagram reassembly. So like segment with TCP, when UDP datagrams are sent to destination, they often take different paths and arrive in the wrong order. UDP server process and request. Like TCP-based application, UDP-based server application are assigned well-known or registered port numbers like as shown. When these application or process are running on the server, they accept the data matched with that assigned port number. The application that use TCP is a great example of how the different layers of TCP/IP protocol should have specific role. TCP handle all tasks associated with dividing the data stream into segments, providing reliability control, controlling data flow, and reordering of segments. So that's all for this chapter 9. Thank you for watching.